So now let's talk about how do continents grow. So one method that they could grow is just due to continued volcanic eruptions. So for example, here's a ocean plate colliding with an ocean plate, and then this one is going underneath it, and then it's melting and materials coming up. We said you get a volcanic island chain as a result of this. Well, due to continued volcanic eruptions, this volcanic island chain can get bigger and bigger and bigger. And so, for example, this is how the Japanese home islands formed. Okay, so you could start off with just a island chain, and eventually it would turn into a micro continent as a result of it. Well, now we want to talk about how a continent can get bigger as a result of collisions. So that you could have a continent over here, and then, so this is our continent, and then out here is in the ocean, and in this ocean you might have little volcanoes out here. And then this plate, though, is being subducted underneath this plate. So eventually this island over here could be carried over to here and eventually be welded onto the continent. So we're going to call this an exotic terrain. It's just other continents and other volcanic materials that can be attached to the side of a pre-existing continent. And so this picture here shows you all the different exotic terrains that have been welded onto the west coast of North America. So that explains how continents get bigger. So now let's talk about how do continents break apart. Well, we mentioned that a divergent zone would do it. So at a divergent zone, the plates are being pulled apart, and then in between, that's going to make a mid-ocean ridge. Well, how does that thing get started in the first place? So what we think at a divergent zone, what's really occurring is you have a series of magma plumes. So a magma plume is a place where you have this lava that is coming up in one spot. So if that lava, so here's your continent right here. And now let's say that right here you have a magma plume that's coming up. Well, what it's going to do is it tends to break the ground apart into three pieces. And movement is going to occur along two of the pieces. Because you can see this plate, let's say, wants to go that way, and this one wants to go this way. Well, it wants to go this way, and it wants to go this way. So do you notice it's very difficult for this plate to separate, because you would need to have movement going that way and that way, but these two are keeping that from occurring. So normally you're going to have plate movement along two of the cracks, but one of them doesn't move. And so that failed rift is going to be called an allocogen. Know that word for the exam. So now let's pretend that you have multiple plumes. So you got a plume that's causing this crack, but now let's say that there's another magma plume over here, and it's causing a crack that goes here and here and here. Well, this crack could connect up with this crack, and now you had a rift zone as a result of it. And then you also have these failed rifts that nothing happens. Well, those failed rifts, you could still have earthquakes that occur along them. And so an example of this is in the Boot Heel region of the state of Missouri in North America. The New Madrid Fault Zone is so active as far as earthquakes is concerned because it's a failed allocogen, or a failed rift. It's an allocogen. Now, I would like for you to know the locations of various geological structures around the world. So you should know where the Rocky Mountains are. and you should know how they came into being. So the Rocky Mountains, for example, was a subduction zone. You should know the Appalachian Mountains. Where are the Appalachian Mountains located at? You should know where the Alps are located at. You should know where the Himalayas are located at. So some major regional structures in North America and in Asia. And then as far as Missouri is concerned, I would like for you to know about the Ouachita Mountains. So the Ouachita Mountains are in northern Arkansas. And so later we're going to find out what caused the Ouachitas to form, but they're going to be related to the Appalachian Mountains. All right, so this picture here shows you the major structures in North America, but if you can just remember the Rocky Mountains and the Appalachian Mountains and then the Ouachita mountain ranges, that will be good enough for the exam. Okay, so that concludes this review, and so I will see you for the next review.